You are in part 3 of our week 5 series. So if you have not viewed part 1 and part 2 yet, please go back and do that, although they certainly are separate. So we're going to dive right into patterns. This one should be a little bit shorter. Just getting you to be familiar with number sense, connecting with algebraic thinking. And as students are building their sense of patterns, our whole numeric system is patterns. We are always 0 through 9 on repeat, and we can see patterns through multiple ways, and we'll talk about it through the lens of math, and then we'll talk about it also through the lens of just real life experiences. So we want to help our students understand that math is just a series of a logical pattern forming over time, and we ask questions to try to find that pattern, and it allows our students to make meaning. I've also found that for some of our students who struggle with maybe ADHD or do not have predictable patterns at home or in their daily life schedule, finding numerical patterns and creating patterns with and for them, like as a schedule of the day, a visual schedule, or just a calendar, your schedule on the board or whatever you use in your classroom, that predictability and that knowing that no matter what, this will be how it's going to be is calming to students, gives them a sense of grounding, and math does that for students. And so you might find that a student who struggles in reading really excels in math because this gives them that structure and that order. Patterns can be numerical, they can be non-numerical, and they're just anything that repeats, like seasons or geometric shapes. And so they will explore patterns 4 ways. First, they'll see it, then they can describe it, then they can extend it, so just adding on to it, and then they'll create their own. And so you've probably seen that with your students, with your own kiddos. And easy patterns that we talk about is like A, B. So they alternate, or 2 A's and then 2 B's, and then you start adding 3 of a kind. In art and music, there's patterns in the way art is designed, the way we do a paper plate, or billboards or bulletin boards, and we can see art all around us. Maybe it's even in landscaping, how trees are spaced out in the schoolyard or the lines on the sidewalk. In music, all songs have a pattern. And so when students connect those, they're doing math. You could do fun games with them to create patterns. Anything that can help them understand that there is a connection. And you wouldn't explicitly say, we're going to clap and snap, clap and snap, clap and snap. You could recognize that, A, B, A, B, A, B, but I wouldn't necessarily say, oh, we're doing math right now. But you're building that algebraic pattern thinking in students, even in the primary grades. So these are critical. And you probably do this already. You do this already in your classrooms as part of your attention grabbers or brain breaks or movement breaks. You're doing these all the time. PE also helps out in algebraic thinking when they go to PE and they're practicing different skills. I know my PE coach is excellent, and he will name it. He will name the pattern, or he will name, just the repeated pattern, and help students know, like, oh, we do this in math. So this is when students can copy the pattern. I like this one too. Sometimes you create an exact number of objects that they will need. So in this case, they will need 5, and 5 circles, and they will need 4 triangles, but they've added a couple more to try to trick them up a little bit and extend that critical thinking, which I really liked. And then you can add the visual with it. I won't spend a lot of time with that. Copying the pattern, AAB, AAB, and these would be duplicated on your smartboard, and so they would just drag and it would move up. Then you could use the physical motion. Once you can either do the physical motion, clap, clap, snap, clap, clap, snap, then the geometric clap, clap, snap, or diamond, diamond, oval, and you can continue doing that. So using a physical motion, then bringing it over to math. And so those are super fun for kids. These are great brain breaks. These are great just implemented throughout your day. Students can create their own. They love doing that. Seeing patterns in the environment. I also love just eliciting that from them and then trying to pull some, take pictures of our campus so you can see it on their campus, or they can, you can draw it. But any way that they can see those patterns in their real life is actually giving them that foundation for algebraic thinking. What manipulatives would you use to support patterns? I know that some of us have mentioned even this week the counting cubes or the geometric like tanagrams. What else can we do when we extend it to fractions? It gets a little trickier, but when in the upper grades, they still love trying to find a pattern. They try to get as tricky as possible, and it's really fun to watch them do that. Just some ideas on also like that pattern thinking. Again, this is a lot of the foundational grades. TK, Kinder 1. Can they name it? So like, can they name either A, B, B, or can they name whatever objects or pictures that you're using? Can they extend it? Can they tell you what's going to come next and why? And that why question at the end is that, extending their understanding, because you want them to be able to say, well, this is the type of pattern that it is. Helping them also understand like attributes and positions. So before, after, shapes, color, sizes, kinds, helping them be aware of just different materials. That is also going to help them extend their thinking. We talked about this a little bit earlier, but recognizing how patterns grow. When we get into some upper grades too, like the pattern will, like if it's a triangular shape, they might flip a triangle around to make the triangle just, if it's an equilateral triangle, an isosceles triangle, they might move it around and say it's just the same thing in the pattern, even though the shape is turned a certain way. And that gets tricky too. Okay. Just activities that students can do. Draw a picture of stage 4 and stage 6. If I had one butterfly and I used 7 blocks, how many would I need if I had 2 butterflies or 3? Now 10. This becomes, I've seen these on state assessments. I've graded state assessments in 2 different states, and this is absolutely something that students have to be able to do. And I think families and educators sometimes think of algebraic thinking as being equations with like numerical values and letters, like variables. Like algebra is not just a variable representing a numeric number, but algebraic thinking is the flexibility that we can think about patterns with numbers, with shapes, with, even abstract. So if basically this is also a building block for multiplication, I'm counting by 7s, basically 7 and then 14 and then 21. So then the strategy is, well, how many geometric shapes or blocks would you need to make 10 butterflies? And it would be unrealistic to have this many geometric shapes. Now, is it possible? And that would be the very, very, very foundational concrete stage for some students, yeah, they could do that and they could get to the right solution that we're looking for. But we want students to think of those number patterns, and can we take it from this picture and then just count by sevens? Okay, 1 butterfly is 7 blocks, 2 butterflies is 14 blocks, 3 butterflies is 21 blocks. And could you build a table, which is what they will be able to know and do, to get to 10 butterflies? This is a super critical, really great activity for teams, for partners, building critical thinking. It could be super fun. Then, of course, they can build their own and ask a question and have partners do it. I mean, this is a great foundational activity for students. Having thematic calendars, I won't read this to you, but basically you're helping keep a pattern going in your classroom. And what I love about these is students can help you. So if you're having, I forget what this picture is here first, but you're creating this pattern where it's 2 pumpkins, and then I think that's a cat, and then a bat, and 2 pumpkins, and that looks like a sheep. I'm not sure, I forget. But your students actually create the next symbol. This one might make a little more sense here. So it is A, B, C, B. A, B, C, B, A, B. And that's a sophisticated calendar. But your students help create. And I love that the bat could be the bat symbol from Batman, or it could be the animal of the bat. And so it becomes super cute when kids start creating it with you. It does not have to be that sophisticated. They did different planets like space shoes, and then Jupiter, Saturn, Earth. And so if you're doing something like this, then it should connect with hopefully your science unit. And then just kind of a, stars, water, it's like a summer pattern. So these are just ways that you are building algebraic thinking for and with your students in really fun ways, because it doesn't have to be, equations and worksheets, and, it could be puzzles and logic games, and that skill will be huge for students all the way up through 12th grade and beyond. So hope you have a great week, and I hope that this was helpful for you.